You can drink your morning coffee every single day, feel completely functional, have decent energy, go about your life, and right now, today, your muscle tissue is disappearing at a speed your bathroom scale cannot detect. Not because you're sick, not because you're doing anything dramatically wrong, because after 55, a specific molecule inside your muscle cells, one that most people have never heard of, one that your doctor has almost certainly never tested, begins running chronically short. And when that molecule runs short, your cells lose the energy capacity to hold on to muscle the way they did at 35. The muscle quietly dissolves. Fat fills the space it leaves behind. The number on your scale stays roughly the same. The composition of your body shifts toward a version that makes everything downstream harder. Your metabolism, your blood sugar, your bone density, your cognitive sharpness, and the process is completely silent. I'm Carol. I read the studies, the meta-analyses, the clinical guidelines, the dry industry reports that nobody should have to read, and then I tell you what they actually say, not what someone paid to summarize them says, not what the supplement brand's website says, what the data actually says, sourced and specific. What I'm about to tell you involves a single ingredient. It takes roughly 4 seconds to add to your existing morning coffee. It costs approximately 30 cents a day. It has been validated in over 500 published studies across 3 decades of research, and it specifically targets the biological mechanism behind that silent cellular energy deficit I just described, which means it addresses the root of the problem, not a symptom. It also does 4 other things to your body that mainstream health coverage has consistently failed to explain clearly, including one thing that affects the organ between your ears that I think will genuinely surprise you. By the end of this, I am going to walk you through what I call the morning anchor stack. 3 specific components, 3 rules, and 1 common mistake that cancels out the entire benefit even when people are doing everything else right. That protocol has a name, and it was not something I found by Googling. It came from reading the research on how these mechanisms interact and assembling what the literature consistently supports into a format a real person can actually execute. Stay for that. But first, and I mean this, you need to understand what you're actually fighting. Because the enemy here is not what you think it is. The invisible villain in this story has a name. It is called sarcopenia. In Greek, that translates approximately to poverty of flesh. I find it darkly amusing that we have a clinical Greek name for something this common and this consequential, and it never appears on a standard annual physical. Your doctor will check your blood pressure, your LDL cholesterol, your fasting blood sugar. Nobody hands you a muscle mass assessment at 55 and says, here is the trajectory you are currently on. Here is the rate at which things are changing. They just don't. So let me give you the trajectory. Starting around age 30, your body begins losing approximately 3 to 5% of muscle mass per decade. That sounds manageable. You can live with 3 to 5% per decade. But here is what changes at 55. The rate accelerates. Research published in the journal Age and Aging, drawing on data from multiple longitudinal studies tracking adults over time, shows that after 60, the annual rate of muscle loss is closer to 1 to 2% per year in adults who are not specifically counteracting it. 1 to 2% per year, every year, compounding. And the reason this matters more than it sounds has almost nothing to do with how you look. Muscle tissue is your body's largest glucose sink. Think of your muscles as a warehouse with a giant holding tank. When you eat carbohydrates, bread, rice, fruit, anything with sugar, your blood glucose rises and your body needs somewhere to put that glucose quickly. The warehouse absorbs it, locks it in, keeps your blood sugar from staying elevated for dangerous amounts of time. A smaller warehouse means the glucose has nowhere to go efficiently, so it lingers in the bloodstream. Your pancreas, the gland responsible for making insulin, the molecular key that opens the warehouse door, has to work harder, produce more insulin, push harder to move that glucose into a storage space that has been quietly shrinking for years. That is one of the core physiological pathways to type 2 diabetes in adults who were never overweight, never particularly sedentary, never obviously unhealthy. The warehouse shrank. The door got harder to open. Nobody measured the warehouse. The metabolic story is only one part. When muscle mass declines, your resting metabolism slows because muscle tissue burns calories even at rest, even while you are sitting perfectly still reading this, and fat tissue largely does not. That is not a myth. That is basic thermodynamics applied to human tissue. Your resting metabolic rate is substantially determined by how much muscle you are carrying. Lose the muscle, slow the furnace, and everything becomes harder. Maintaining body weight, managing blood sugar, recovering from illness, and then there is the bone connection. Bone and muscle are physiologically linked through a mechanism called mechanotransduction, which is the scientific term for how mechanical force gets converted into a biological signal. When a muscle contracts and pulls on a bone, that tension signals the bone to maintain and deposit new mineral. It is the body's way of saying, something here is demanding strength, so let us maintain structural density to meet that demand. Weaker muscle means weaker signal. Weaker signal means lower bone density over time. And that is how osteoporosis and sarcopenia tend to appear together in the same people, because they share the same upstream driver. Then there is the research from the Rush Memory and Aging Project, which followed more than 900 older adults for years. Lower muscle strength was associated with faster cognitive decline in those participants, independently of cardiovascular disease, depression, sleep quality, and education level. The connection between muscle and brain is not metaphorical, it is biological, bidirectional, and measurable. Muscles release signaling molecules during contraction, a category of proteins called myokines that cross the blood-brain barrier and support neuroplasticity, meaning the brain's ability to rewire and maintain its connections. When the muscle isn't there to send those signals, the brain receives less of a stimulus to maintain itself. The muscle is not a vanity organ. It is the physical substrate of your metabolism, your insulin sensitivity, your bone architecture, and your cognitive trajectory after 55. And the process of losing it has been happening without a diagnosis, without a conversation at your annual physical, and without a single pharmaceutical company running advertisements about it. I find that genuinely interesting, not outrageous, because the reason there are no ads is that the intervention that works most effectively is not patentable. You cannot patent a molecule that has been available as a generic supplement since the 1990s. That molecule is creatine monohydrate. I know what some of you are picturing right now. Giant tubs with shirtless men on the label. Gym culture, something that belongs to a 23-year-old who cares about bench press numbers and nothing else. That image is a product of how creatine has been marketed for 30 years, at a specific demographic that is not you, and it is the single biggest reason why the population most supported by the research has been the last to benefit from it. The supplement industry found its customer in gym culture, built its visual language around gym culture, and the people over 55 who needed the biology never received the message. The research, meanwhile, kept accumulating. More than 500 studies, an established position paper from the International Society of Sports Nutrition, calling creatine monohydrate one of the most extensively studied and effective nutritional supplements that exists. And almost none of that signal reached the people over 55 watching health content on their phones. So let me explain what creatine actually is, stripped of every bodybuilder connotation, because the mechanism is what matters, and the mechanism is why this works differently at 55 than it did at 25. Your muscles and your brain run on a molecule called adenosine triphosphate, ATP. You do not need to remember that name. Think of ATP as the only currency your cells will accept as payment for energy. Every time a muscle fiber contracts, to take a step, to pick something up, to catch yourself when you stumble, it spends one unit of that currency. The cell immediately needs to reload that currency to keep going. The primary mechanism for rapid reloading is a compound called phosphocreatine, a version of creatine that is pre-charged and ready to donate energy to a spent ATP molecule in a fraction of a second. Think of it as the difference between a power bank that can recharge your phone in 15 minutes versus one that takes 6 hours overnight. The speed of that reload determines how hard and how long your muscle can work, and how effectively it can complete the repair and maintenance cycles that happen after physical activity. Here is the part that directly connects to everything I described about sarcopenia. After 55, two things happen simultaneously that erode this system. First, dietary creatine intake tends to decline. Because creatine exists naturally almost exclusively in red meat and fish, and many older adults consciously reduce both for health reasons, habit changes, or appetite shifts. Second, the efficiency of your body's internal creatine synthesis decreases slightly with age. The result is a phosphocreatine system that operates at chronically reduced capacity, not broken, not empty, but consistently running below the level needed to fully support muscle protein synthesis and the cellular repair processes that maintain muscle mass over time. The fast charger is still there, it is just not charged to full. And nobody told you because there is no standard test for it and no prescription to write. Now, here is the mainstream betrayal moment. The part of this story where the information you have been given is not wrong exactly, but importantly incomplete in a way that has likely cost you years. We have been told, through mainstream health journalism, through general practitioner advice, through fitness content aimed at older adults, that muscle loss after 55 is primarily a hormone problem. Declining testosterone in men, declining estrogen in women, declining growth hormone across both sexes. And those hormonal changes are real and they matter. I am not dismissing them. But a 2022 consensus paper published by the International Society of Sports Nutrition, reviewing the full accumulated body of creatine research, concluded that creatine supplementation independently supports muscle maintenance in older adults through the cellular energy mechanism, and that this benefit operates below the hormonal level, meaning even in a body where testosterone has declined, even in a body where estrogen has dropped post-menopause, the phosphocreatine reload system still functions, and it still responds to additional creatine substrate. Hormones set the ceiling for how much muscle you can build or maintain. Creatine helps you actually reach that ceiling. The hormonal story and the cellular energy story are not the same story. That distinction matters practically because it means the intervention is available to everyone, not just people who are candidates for hormone therapy, not just people whose hormone levels come back flagged on blood work. If you are over 55 and you have a muscle you would like to maintain, the phosphocreatine mechanism is active in that muscle, and it responds to creatine supplementation. That is what the literature consistently says. Now let us go through the specific benefits in order from real and useful to genuinely surprising. This is a countdown. Number 1 is last, because it is the most mechanistically complete explanation of why the cellular energy system is the upstream variable that determines your muscle trajectory, and I want you to actually understand it, not just hear it as a claim. Number 6. Raw cellular energy during the tasks that actually keep you safe. Most people assume creatine makes a meaningful difference only during intense, sustained exercise, the kind that happens in gyms. This assumption is wrong, and understanding why matters for people over 55 specifically. The phosphocreatine system is most active during sudden, powerful bursts of muscular effort, the kind required when you catch yourself tripping on a curb, when you climb a flight of stairs carrying something heavy, when you get up quickly from a low chair, when you need to react physically to something unexpected. These are explosive, short-duration demands, and they are powered almost entirely by the phosphocreatine reload station, not by longer aerobic pathways. Research published in the Journal of Strength and Conditioning Research found that older adults supplementing with creatine monohydrate showed measurable improvements in lower body power output, specifically their ability to generate force rapidly, within 4 weeks of beginning supplementation. That rapid force generation is precisely the physical capacity that protects you from fall-related fractures. According to the Centers for Disease Control and Prevention, falls are the leading cause of fatal injury among adults over 65. 1 in 5 adults over 65 who sustains a hip fracture dies within 12 months of the injury, not from the fracture directly, but from the cascade of complications that follow immobility. Creatine's most immediate value for someone over 55 is not aesthetic. It is the rebuilding of fast-twitch muscle capacity for the split-second physical responses that keep you upright in the real world. Number 5. Blood sugar regulation and insulin sensitivity, the warehouse mechanism revisited. Creatine has been shown in multiple controlled trials to improve what researchers call glucose tolerance, your body's ability to manage a rise in blood sugar without triggering an excessive insulin response. The mechanism involves a protein called GLUT4, which functions like a specialized doorway embedded in muscle cell walls that glucose uses to enter storage. Under normal conditions, insulin activates these doorways. Creatine supplementation has been shown to enhance what is called GLUT4 translocation, moving more of these doorways to the surface of the cell, making the warehouse more accessible to incoming glucose. The doorways are closer to the entrance. Traffic flows faster. Blood sugar spikes become shorter and shallower. A study published in the journal Medicine and Science in Sports and Exercise found that creatine combined with exercise improved insulin sensitivity in older adults significantly more than exercise alone, not marginally more, but substantially more, in a way that held up across the duration of the trial. This matters long-term because pancreatic exhaustion, the gradual burnout of insulin-producing cells from decades of overwork compensating for insulin resistance, is one of the core pathways to type 2 diabetes in people who had no metabolic warning signs at 40. Creatine does not treat diabetes, but it is one of the most underappreciated nutritional tools in the literature for preserving the glucose machinery that was working efficiently 15 years ago and has been slowly degrading since. Number 4. Bone mineral density, the structural benefit most people never connect to creatine. As I described earlier, bone responds to the mechanical force that muscle applies to it. The bone is a living material that only maintains its density if it receives consistent signals that structural strength is needed. Creatine's role here is indirect but meaningful. By supporting the energy system inside muscle cells, creatine allows those muscles to generate more force during resistance training, and more force means a stronger signal to the bone to maintain density. A 2018 meta-analysis published in the journal Osteoporosis International, pooling data from multiple randomized controlled trials in older adults, found that creatine supplementation combined with resistance training produced significantly greater improvements in bone mineral content, particularly at the hip and lumbar spine, which are the fracture sites that carry the greatest consequences, compared to resistance training without creatine. The effect size was modest but consistent across studies, and modest but consistent in the context of bone mineral density at 65 means the difference between a fall that results in a fracture and a fall that doesn't. The bone and muscle systems are not independent. They run on overlapping mechanisms. Supporting one supports the other. Number 3. The cardiovascular angle and the homocysteine connection that almost nobody explains. Here is a piece of biology that most health content has never bothered to tell you. Your liver and kidneys synthesize creatine internally from raw amino acid material. That synthesis process is biochemically expensive. It consumes molecular building blocks, specifically methyl groups donated by a compound called S-adenosylmethionine, and it generates a byproduct called homocysteine. If those words mean nothing to you, here is the one-sentence translation. When your body has to work hard to make its own creatine from scratch, the manufacturing process creates waste that accumulates in your bloodstream. Homocysteine is that waste, and at elevated levels, it is independently associated with increased risk of heart attack, stroke, and cognitive decline. Multiple large-scale epidemiological studies have confirmed the homocysteine cardiovascular risk link. When you supplement with creatine, your body no longer needs to manufacture it at full capacity internally. The synthesis pathway quiets down. Less homocysteine is generated as a byproduct. The manufacturing waste stops piling up. Multiple studies, including research published in the British Journal of Nutrition, have documented measurable reductions in plasma homocysteine in response to creatine supplementation. This is entirely separate from the muscle mechanism. It has nothing to do with gym performance. It is a cardiovascular benefit operating through a biochemical pathway that most general practitioners have never been trained to connect to creatine. I want to say something personal here because it is directly relevant to why I take this particular mechanism seriously. When my husband had his cardiac arrest about 5 years ago, the result of years of an overloaded, sleep deprived, convenience food lifestyle, his cardiologist ran a full panel afterward. His homocysteine was elevated, not flagged as dangerously high on the standard reference range, but sitting in the upper portion of what most labs consider normal, which, when I started reading the research, I found was still a range associated with meaningfully higher cardiovascular event risk. Nobody had tested it before. There was no warning, no conversation, no recommendation to address it. We only found out because a near-fatal event prompted a thorough workup. He is doing well now, under ongoing medical supervision, on a carefully managed protocol that involves both medication and significant lifestyle changes. And I want to be absolutely clear that creatine is not a cardiac treatment, that his recovery has been a long supervised process, and that individual results vary enormously. But the homocysteine mechanism is real, it is documented, and it is the kind of thing that sits in the scientific literature while mainstream health content runs pieces on green smoothies. I find that absurd, not outrageous, just absurd. Number 2. The brain and three mechanisms most people have never heard of together. Your brain uses a significant portion of the body's creatine stores despite being a relatively small organ by weight. The reason is that the brain is an extraordinarily energy-demanding organ, and it uses the same phosphocreatine rapid reload system that muscles do, particularly during periods of sustained cognitive effort, problem-solving, emotional regulation, and working memory. When you are holding a complex conversation, tracking multiple variables at once, trying to remember something you are sure you know, your brain's neurons are burning ATP at high rates, and the phosphocreatine system is responsible for keeping those neurons rapidly recharged. A randomized controlled trial published in the Proceedings of the Royal Society of Biological Sciences, conducted by researchers in Australia, found that 6 weeks of creatine supplementation produced significant improvements in working memory performance and processing speed in healthy adults. Separately, research has consistently documented that vegetarians, who consume essentially zero dietary creatine because it is found almost exclusively in animal muscle tissue, show the largest cognitive improvements from supplementation, with measurable increases in brain creatine levels confirmed by magnetic resonance spectroscopy. The principle scales down to any adult whose dietary creatine is lower than it once was, which describes most adults over 55 who have shifted away from heavy red meat consumption. There is a second brain mechanism worth understanding: sleep resilience. Adults over 55 frequently deal with disrupted or shortened sleep, whether from hormonal changes, medication side effects, stress, or simply the altered sleep architecture that comes with aging. A study from researchers in Canada found that creatine supplementation partially compensated for the cognitive performance decline caused by sleep deprivation. The mechanism is the same. Sleep-deprived neurons are running on depleted energy reserves, and more available phosphocreatine helps maintain function under that energetic stress. Creatine does not replace sleep, but if you have been sleeping poorly and wondering why your thinking feels slower, your cellular energy reserve is one variable that is genuinely modifiable. The third brain angle is the most recent and the one I think deserves more attention. A 2023 randomized controlled trial from the University of Utah, published in Bipolar Disorders and covered in multiple psychiatry journals, found that creatine supplementation showed significant antidepressant effects as an add-on treatment, particularly in women. The proposed mechanism involves creatine's role in supporting mitochondrial function in brain cells. Mitochondria are the power plants inside cells, and depression is increasingly understood, at least in part, as a condition of cellular energy failure in specific brain regions. If the mitochondria and prefrontal cortex neurons cannot produce ATP fast enough, the neural circuits involved in mood regulation, motivation, and executive function run at reduced capacity. Creatine provides the substrate those mitochondria need to run efficiently. This research is new enough that I would not call it definitive, but the biological coherence is strong, and the effect sizes in the trials are not trivial. For women over 55 dealing with low mood, low motivation, or what gets generically labeled as brain fog, the creatine mechanism is worth knowing about because it operates entirely differently from anything currently being prescribed for those symptoms. Number 1. the sarcopenia reversal, and why understanding the satellite cell mechanism changes what you should be doing every morning for the rest of your life. Here is what most people believe about muscle loss after 55. They believe it is primarily hormonal and therefore mostly irreversible without hormone intervention. They believe it mostly affects people who are sedentary. They believe that if they are already exercising, they are doing everything they can. All three of those beliefs are incomplete in ways that are directly consequential for what you should be doing tomorrow morning. Let me give you the mechanism from the ground up. Inside every skeletal muscle fiber, there exists a population of dormant stem cells called satellite cells. These are your muscle's internal repair and construction crew. When a muscle fiber undergoes stress, from exercise, from any demanding physical activity, from anything that challenges it beyond its comfort level, the satellite cells activate. They wake up, divide, and fuse with the stressed fiber, donating new cellular machinery, new nuclei, new protein synthesis capacity. This is how muscle is built and maintained throughout an entire human lifespan. The satellite cells never fully stop working. They are still present and still functional in a 70-year-old. The question is not whether they can do their job, they can. The question is whether they have enough energy to complete the job when they try. Here is the specific failure point. The activation, division, and fusion process that satellite cells go through is energetically expensive. It requires a rapid, sustained supply of ATP during a very specific window of cellular activity. If the phosphocreatine system inside those muscle fibers is running at chronically reduced capacity, which, as I described, is exactly what happens with age-related declines in dietary creatine intake and internal synthesis efficiency, the satellite cells do not have adequate fast energy to fully complete the repair and growth cycle. They wake up, they begin the work, they run out of cellular fuel before the job is finished. The repair is partial. The fiber is maintained at a slightly lower level than it was. Multiply that across every physical effort, every walk, every session of exercise, every climb of stairs, over years, and what you get is the gradual, invisible, scale-defeating muscle loss that defines sarcopenia. A meta-analysis published in the journal Medicine and Science in Sports and Exercise, pooling results from 22 randomized controlled trials specifically in older adults, found that those who supplemented with creatine while engaging in resistance training gained an average of 1.37 kilograms more lean muscle mass than those who did the same resistance training without creatine. 1.37 kilograms. The placebo group was not sitting on the couch. They were doing the exercise. They were providing the stimulus. Their satellite cells were being recruited. But their cellular energy system was running on a partially depleted phosphocreatine reserve, and the repair cycle was consistently finishing below its potential. The creatine group gave those construction workers a full fuel supply for every session. Same blueprint, same workers, same hours, adequate energy, more muscle maintained and built. The difference is not insignificant. It represents a measurable reversal of the trajectory that would otherwise compound in the wrong direction every year from 55 onward. Here is what that means for you right now, today. If you are exercising, eating reasonably, getting enough sleep, and still slowly losing ground, still feeling that your body composition is drifting, still noticing that things feel harder than they did at 45, the missing variable may not be effort, may not be discipline, may not be anything you are doing wrong. It may be that your cell's rapid energy regeneration system has been running on low for years, and nothing in your current routine is restoring it. That is what creatine monohydrate addresses, not indirectly, not as a side effect, as a primary mechanism that is documented in the peer-reviewed literature across hundreds of studies. Now here is the morning anchor stack. 3 components, 3 rules, 1 mistake. The anchor itself, 3 to 5 grams of creatine monohydrate in your morning coffee every single day without exception. Not creatine hydrochloride, not creatine ethyl ester, not buffered creatine, not any of the modified forms sold at a premium. Monohydrate. It has the deepest evidence base, the highest bioavailability of any studied form, and it costs a fraction of the alternatives. You do not need a loading phase. The old protocol of 20 grams per day for 5 to 7 days was designed for competitive athletes trying to saturate tissue as rapidly as possible before a competition. For adults over 55 focused on muscle maintenance, cognitive support, and metabolic health, research supports starting directly at 3 to 5 grams daily, reaching full tissue saturation within 3 to 4 weeks, with no need to rush. Creatine monohydrate is heat stable. It does not break down in hot liquid, does not react with caffeine in any meaningful way, despite an old study suggesting otherwise, and that old study's finding has not replicated in subsequent research. It dissolves completely. It has essentially no taste and no odor. Your coffee will be indistinguishable from what you drink right now. The protein anchor. Creatine supports the energy environment that allows muscle protein synthesis to run at full capacity. But you also need the raw material, dietary amino acids, to actually build the structure. Research published in the American Journal of Clinical Nutrition and consistently replicated across aging studies shows that adults over 55 require between 1.2 and 1.6 grams of protein per kilogram of body weight per day. That is substantially higher than the official recommended dietary allowance of 0.8 grams, which was calculated to prevent deficiency in young adults, not to preserve muscle mass in people over 55. If you weigh 80 kilograms, roughly 175 pounds, you need between 96 and 128 grams of protein daily. The average older adult is getting somewhere between 50 and 65 grams. That gap is where sarcopenia lives. Creatine without adequate protein is a fully charged power tool in a room with no raw materials. Both sides of the equation must be in place. The resistance stimulus. Creatine does not build or preserve muscle passively. It builds muscle by improving the cellular energy environment inside fibers that are actively being challenged. Without the stimulus, the satellite cells are not being recruited. The phosphocreatine system has nothing to amplify. Research from McMaster University, one of the world's leading centers for aging and muscle research, is unambiguous. Creatine's muscle benefit in older adults is substantially larger when combined with resistance exercise than when taken in isolation. The resistance stimulus does not require heavy weights. 2 to 3 sessions per week of any resistance modality, bodyweight movements, resistance bands, machines, free weights, at an effort level where the final 2 to 3 repetitions of each set are genuinely difficult, not comfortable, not easy, but requiring actual effort to complete. That effortful final phase is what recruits the satellite cells. Without it, the creatine has no amplification target. The one mistake that invalidates the protocol: stopping. Some people cycle creatine off periodically because they have read that you should cycle supplements. Creatine is not a hormone. It is not a stimulant. Your body does not develop tolerance to it, does not downregulate its own creatine pathways in a meaningful long-term way, and does not require breaks. When you stop supplementing, tissue creatine levels return to pre-supplementation baseline within 4 to 6 weeks. The benefits disappear with the creatine. The meta-analyses showing the greatest effects on lean mass were in adults supplementing consistently for 12 weeks or longer, not cycling, not stopping, not taking 2 weeks off every month. You take it daily, indefinitely, the way you drink the coffee it goes into. That is the entire protocol. One responsible note before I close, because I take this seriously and I have seen what happens when people treat supplement advice carelessly. If you have chronic kidney disease, or if you have been told that your kidney function is compromised in any way, talk to your doctor before supplementing with creatine. The evidence for creatine's safety in healthy kidneys is extremely strong. This concern has been tested extensively and largely dismissed in people with normal kidney function. But the data in people with pre-existing kidney impairment is less comprehensive, and that population warrants a conversation with their physician before starting. For everyone else, tell your doctor what you are adding. Not because you need permission, because your doctor needs your full picture to give you useful advice. My husband told his cardiologist every single change we made to his nutrition protocol, including when we started adding creatine to his morning coffee. That is what working within a medical relationship looks like in practice. Here is where I land after reading this research for years and watching what actually moves the needle in people over 55. The interventions that consistently work, that have the deepest evidence and the most consistent effect sizes, are almost always the ones without patent protection. Nobody owns creatine monohydrate. There is no company with a $3 billion marketing budget pushing it toward the demographic the research most supports. So it sits in the gym supplement aisle, marketed to 23-year-olds, while the people the science most consistently points toward have been drinking their morning coffee without it for decades, attributing their slowly declining energy, slowly declining muscle mass, slowly declining cognitive speed to simply getting older. Some of that trajectory is biology. Some of it is a phosphocreatine deficit. The difference between those two explanations is 3 to 5 grams per day and 30 cents. That gap has existed in plain sight in the scientific literature for 30 years. That it has not reached the people who need it most is not a mystery. It is a distribution problem. And distribution is something you can do something about. If you are starting the Morning Anchor stack this week, comment the word anchor below. I want to see who is actually doing this. Come back in 60 days and tell me what you noticed. If this video shifted your understanding of what muscle loss actually is and what your morning coffee is capable of doing differently starting tomorrow, share it with one person over 55 who needs to hear it. Subscribe to Carol Thriving Past 55. I read the boring stuff. You get the part that matters.